Hello, everyone. Welcome to our regular bi-weekly core protocol sync. We'll be sharing what we've been working on the consensus and networking and related stuff over the last 2 weeks. And we'll also be sharing plans for the future. And Shamil will kick us off as usual with the networking stuff.
Sure. A couple of weeks ago, we started our Gemini 3D network, and after several days, it got unresponsive port, despite that we have at the moment probably 70 peers tops, and that was very unexpected. So I started to investigate what was going on. The initial idea was that we just ran into connection limits, which was also strange because the default connection limits were something about 300, and for 2 connections per peer, 70 peers, it shouldn't be the case. However, it was indeed we ran into connection limits. I changed it to 1,000, but it didn't help. Further investigation showed that actually our Gemini 3C joined the fun, and we basically were DDoSed by our own network, Gemini 3C. And also there was an idea that Subspace bootstrap application that we use to bootstrap the network somehow performs too many work for some for connection handling. So I profiled it, I installed some debugging tools into the container and ran it within the container. Turns out that the CPU work was mostly for establishing connection indeed, something about 60%, if I'm not mistaken, about this all the connections, upgrades, and handshakes. So we spent all the time just for connection handling. So there are several ideas what to do. The first one is to implement network partitioning, the similar that Substrate has. This is that we add some designator for the network, which probably Genesis hash is a good example. Substrate uses it. So every protocol in Substrate uses Genesis hash as part of its name. So when the P2P network peers connect to each other, they exchange these protocol names, and they can decide what to do next. So I implemented already today the same partitioning for the first protocol set, which is Kademlia and GossipSub. I added also Genesis hash to the network, and if Genesis hash is different from what we expect, we just make the cleaning job. We ban the peer from the network immediately, drop all the connections. Also, we clear known peers cache, and we clear the Kademlia routing table. So currently, I implemented that policy to network partitioning for GossipSub and Kademlia. It should be enough for us to be partitioned from other networking. However, I will probably add the same partitioning for the request responses protocol as well, just to be sure that we don't serve any other requests if we don't. It's kind of arbitrary, but just to be sure that we have this also partitioned. I think this is a good idea if we change the port when we start our next network, in order to not have all these connections to the same bootstrap applications, because the way connection limits work and peer banning also works the same, that we first make all these connection upgrades, and later we decide whether we ban peer or whether we disconnect it because of connection limits. So I suggest to change the default port for our bootstrap application for the next network. But this is the symptom of the root problem. The root problem is that we have too many connections for our application, and we have several ways how to change that. The first one that we currently use connections to the peers very rarely. For example, when we get a piece using the request response protocol, it's highly likely that we use the same connection only once because we have connection timeout as 10 seconds by default, and it's not clear whether we'll use the same peer for the next piece request. So one of the ideas to change that is to include some hints, whether in connection in the request or response on the pieces available on the peers. For example, a peer could paste some information about what other pieces it's need into the request, and the response could contain more peers than just than now, because the same could be done in several different ways. For example, implementing some kind of peer info protocol to exchange what pieces these peers contain. This is one of the way forward. Another one is much simpler from the conceptual side, is we increase the piece size, which we will do anyway in some future. I'm not sure whether it's near future or in several months. For example, we plan to use probably 1 megabyte per piece. This is 30 times greater than we use now. And this will decrease this connection establishment and requests 30 times as well. So it will be a simple improvement. Another idea, I need to elaborate it more, but I think there is a way how could we capture the fact that that there is a relationship between piece indexes for the new pieces and segment indexes, because when we publish segment, I think there is a way how to predict these piece indexes, but I will think about it more. That's it. So I changed this network partitioning. I also fixed that I fixed that the algorithm that I implemented earlier that pauses the DSN requests when we don't have the connections to the DSN. I fixed it because previous solution generated these pairs: connection established, connection lost, connection established is lost, because the way that the connection limits are implemented now, that we establish connection first and then we close it. So this connection to the DSN was kind of false signal. I changed that by adding some grace periods. Currently, I need to be sure and wait several seconds before I check that. I said that JSON connection is established, and all the operations are resumed. So there is several seconds delay. Basically, I need to pass several checks that connection is established. That's it. I think that I will finish this request response protocol partitioning this week, and also return to my long-running tasks previously that I started previously, which is Academia announcing. That's it.
So for Gemini 3D, what are the next steps to kind of fix it? Do we deploy the changes you made using the Genesis hash?
Could we start Gemini 3E?
I don't think it's necessary. Since our DSN is effectively not working, we can actually break it, and we can then deploy a new version of networking for DSN, and then
Yes.
we can ask people
I'm
to
worried
upgrade.
about the port in the chain spec for bootstrapping.
Well,
Because
we
if
can update that. The chain spec bootstrap addresses are not part of the Genesis hash and stuff like
okay,
that, so they
okay,
can be
then
updated.
that works as well. It will work. Okay.
So what's the timing you guys think on being able
I think I hope that Nazar will pass it in 2 days at most. Then I think it's Thursday or Wednesday. We could try in some limited form.
It was a little bit unexpected that our Gemini 3C decided to join Gemini 3D party. I think some users just configured it a little bit wrong, and then they connected together, and then there is no going back.
I
But
have
that's why
another
we
view
have
on
test
that.
networks, I guess.
I think since we have the same IP address for the different DNS address, so probably some peer just joined
Not
that.
really. The identities are different. I have checked. The identities would have been different anyway, so you couldn't connect to the same URL. So someone must have configured it in a way where it joins both somehow.
And then propagates this information
And
across
it will propagate automatically from there on. Yeah.
Yes. Okay.
Interesting how it happened, but
This changing the piece size to 1 megabyte or doing that fix, is that something that's like, of these, I guess, getting at the root problem, the too many connections, which of these are we leaning to first? Would it make sense just to go ahead and, if we're going to be moving to 1 megabyte on the piece size, to do that sooner
It's
rather
depend
than
on the consensus work. It's much easier from my side to implement this than from the consensus part, because way I see it from the JSN part point of view, I need to just to test that it works in 1 megabyte pieces. Change some timeout, change some maximum request size. Most problems that I could see from that to change from request response protocol to bit swap protocol, but it's still will be easier than from consensus part.
Well, I would say that it's actually a good thing that we have a small piece size right now, because we are running in more pathological edge cases that we can discover earlier. With bigger piece size, we will see less of them, but then we will also have less kind of stress test on the network. The thing is right now is that as you are syncing on the network, let's say, or you are plotting, you are announcing much more things compared to what you would have been doing if you had bigger piece size. So you have like 30x more announcements, which is much more stress on the network. And it's a good thing that, because if you can handle that kind of stress, then we will surely have no problems when we have bigger pieces. So
that's correct. I would also add that bigger pieces would solve one of another issue that we have, that we don't saturate our network bandwidths. So I
likely,
expect that if we change that, we will have more usage of our networking. I mean that network cards for the local users.
Well, I've been working on implementation of the consensus for, I don't know, more than a week, and this whole time it is 1 megabyte in there. So it's just a matter of time when we merge it.
Great. Could you briefly describe what are the obstacles before that, or what are the obstacles
I will share in my
that
update.
prevents us
I will
to
go through everything.
10 megabytes, make it 10 megabytes instead of 1 megabyte?
Okay, we can go into that as well.
Okay.
But first, Rahul, what were your updates? How is compact blocks going?
Yeah, so this week I implemented the compact logs and I have it working in my branch. I was able to test it locally in my 2-node setup. But the main issue I discovered is like it somehow always goes into the slow path, where the node downloads the compact response and it doesn't find any of those hash transactions in its local pool. So it always ends up requesting it from the peer. So that's what I'm debugging now. I have a couple of ideas what could be happening. I'm going to I'm trying it right now and see what exactly is causing it, because that would be kind of a critical thing to do if you want to do the block relay optimizations. We may actually end up slowing down things if we don't have if we can find things in the local transaction pool. So that is where I am right now. And last night, Jeremiah mentioned like he would like to see it in test devnet. I may need some help from Nazar or someone to bootstrap that, because I haven't done that before. I don't know exactly how the configuration looks, like how many nodes and what needs to run and stuff like that. So maybe I'll ping Nazar maybe later today to figure out the details. And I also need to do the benchmarking once I figure out this issue this week.
I think probably
okay. And what
that
is the
in
time box for that?
Sorry.
What is the time box for this debugging process?
So I'm planning today. Hopefully by today I should have enough information. Yeah, by today I should be done with it, or at least I should have enough information to go on. After that, we can proceed to the next stage, I think.
was gonna say for the DevNet, I would ping Ved and Mohammed.
Where
They
in
should be,
okay.
yeah, they should be able to.
Okay, yeah. So could you briefly explain like how it looks like usually the test DevNet, how many nodes we have and what kind of load runs on it? Nothing.
4 nodes right now. Each one corresponds to individual category. Like there's an RPC node that runs all the domain stuff, and there is a full node, and there is a farmer node, and there is your bootstrap node. Those are 4 nodes running on DigitalOcean right now.
Oh, so I see. So I need to spin up these 4 nodes fresh for my testing. Is that correct?
Yeah, sure. Go for it. Like I think Mohammed could be able to assist you on that. If not, I can jump in there.
I see. Okay. And also, how do we push the binaries to these nodes?
We prefer Docker. It's much more easier that way. Maybe make a snapshot like we do, and then we can just deploy and prune the network and start a new network for you.
I see. Okay, maybe yeah, I'll probably need more follow-up details. I'll ping you maybe a little later. I don't know.
If you want to deploy something from your fork that is not even merged, you can do that as well. You can just create your own fork. You can run CI there. It will build everything. You can run it. Like you can do a lot of things.
I see. Okay, I can. Okay, I have a CI already, so I can use that. Fine. No, that's great. Cool. Yeah. So I hope to find more on this today, because it is. I see some pretty weird behavior with Substrate. What happens is like a node downloads proposes a block, and after some time he also downloads it, the same block that he earlier proposed from a peer. So I don't know why he does that. I'm trying to understand that as well. I mean, my worry is like our changes are not causing this behavior. I may need to test with like the main Substrate, the fork that we have, to make sure like we see the same behavior even without our changes. But that would be after I finish this debugging.
I don't think we have changed anything in that regard. We have just like added some fields, but we have not changed behavior. How we
Yeah,
block.
you know, I just want to like my changes are not causing this weirdness. So I want to just take the subspace dash b4 branch as is and try it out once to make sure like things are in order. Yeah. Because other factors like the way I test, right? I have these 2 nodes running in my local MacBook, and they do a lot of funny things. So I hope like that is not doing something bad. Yeah. So that's it for me.
All right. Any other questions to Rahul?
That's it mostly. I made reach out to a bunch of people to create the DevNet, but apart from that, I don't have anything more.
Okay. A lot of fun things. Sounds fun. Okay.
Yeah. Also, I'm kind of other thing. I'm going on PTO coming Friday to next Wednesday, so I would need to get the DevNet thing running before that. So hopefully I can get it.
Yeah.
I mean, deploy. So when
Hello. You
I
froze.
think that was broken up for us. Yeah.
You froze. Wait, you're saying something?
deploy. So
Okay. I think it's happening again.
Okay.
All right. Let's switch to the more consensus related stuff. I'll share my GitHub pull requests. This will probably be the easiest to track. Basically, I was working on things locally and I was extracting different things from the working branch. One of them was some of the refactorings. For instance, this refactoring introduces 2 new types. One is for segment index. Previously, it was just a type alias. And the other one, similarly for the piece index, it was type alias as well before. Why is we have more type safety and we have useful methods on them. So for instance, there are many places where we are doing this like multiplication, division, subtraction, addition that is easy to get wrong in one of the places and then have issues. So now we have a few constants for popular segment indices that we have. And then also we have useful methods where we can find the piece index of the first piece in this segment, or we can get all of the indices, or we can get just the source ones, because in some cases we care about sources so we can reconstruct data faster. So we just encapsulate a lot of that logic in here, and then we have semantic methods in the rest of the code base without doing these bits and bytes manually. And the same for piece index. We can, for instance, iterate over them. I have implemented this unstable feature where we can use this in ranges rather than just U64. So initially, a version of the pull request contained a lot of transformations back and forth. But there is an unstable feature. We have so many unstable features. Rust nightly is so amazing compared to stable. And then there are also useful methods, for instance, same 0 and 1 piece index, and we could also figure out what segment index it corresponds to instead of manually multiplying and dividing things. So this is just a simple refactoring. The rest of the changes are just using those types. There was another refactoring related to archived segments. Basically naming. We have been discussing the new specification with Daria, and we have discovered that there are a lot of naming inconsistencies. What we ended up doing is agreeing that we had Subspace archiver that contained archived segment. It actually is a new archived segment. Let me change this for prosperity. New archived segment. That's how we ended up calling it. Which is data structure which returns information about the segment that was just archived. We had we didn't really have a data structure for archived segment. It was just a series of pieces. Now we have this more semantic version of that, which is called archived history segment, which means segment that was archived, so after archiving. And then we also have recorded history segment, which is the segment that we have collected from pieces, but we have not archived yet. So now we have raw pieces which are contained within recorded history segment, and then we have regular we have raw records, and then we have regular records and pieces in this archived version. So we have like separation before and after. And again, all of that is used across different places, and we have those data structures in pieces and segments modules of the Subspace core primitives. So it's somewhat pleasant to work with them, and everything else uses them. I probably don't want to go into too much details, but that is the gist of it. Make it more nicer to work with and harder to misuse, and the naming is more consistent now. Because previously we had segment, which is archived segment in the archiver. We have also archived segment before archiving. We have also archived segment after archiving, like segments everywhere. Hard to make sense which one we were talking about. Now we have clear distinction between them. Okay, then as I increased the piece size that we have just talked about, the performance was really terrible. And I was trying to find a way to make archiver a little bit faster so I can at least run benchmarks and tests locally without waiting for 10 minutes on each iteration. I don't remember which changes were here. So basically, we have several things in archiver. We have incremental record commitments, which basically is the idea that our history normally, when we are just running the node and we are producing blocks, it grows slowly, relatively speaking. So we will likely add one more record at a time when a new block is produced, rather than producing the whole segment at once. What that means is because our archiving takes time, and it's a significant amount of time if we are archiving the whole segment at once, we can actually create those commitments incrementally as they are produced instead of at the very end. So we can amortize the cost, amortize this time across longer time span. So there is this module that does that. The way it did it before, it was ingesting data and it was producing new commitments one after another. However, in tests and benchmarks, we sometimes do send a big blob of data, which actually has a lot of potentially commitments in there. So this pull request basically changes that to actually produce them in parallel when there are multiple. So in the archiver, we are using Rayon, and it's an optional feature. And for some of the iterations, we are actually optionally using parallel iterators, and we are producing the stuff in batches. And that was helping with performance a lot. In my case, it was, I believe, about 2x improvement in this case. And I believe Shamil also wrote that it was faster, or maybe it was a different pull request. So basically, there are a few of these that are trying to improve performance, at least by using more CPU threads, if not possible to just eliminate computation. Then there was an interesting edge case as I was thinking about this issue. There was an interesting report where we are supposedly building a block on top of a time slot on top of the same time slot, which makes zero sense. And there is actually a check in the SC consensus slots in Substrate, which makes sure we are not trying to claim the same slot twice, but there was no check about the parent slot. So the parent block could have had the same time slot, and due to clock difference, we could have tried to build the same time slot on top of the same time slot. So in our implementation of that, in the claim slot, we have additional check, which extracts the parent slot. And if the parent slot is same as the current one, then we kind of cannot really produce a block, so we will skip it. That's the whole change in this pull request. It will remove that particular error. I don't really see a generic way to actually handle it in SC consensus slots because it doesn't know where time slot is stored within the block. It's like chain specific kind of thing in this data structure. So there was that. Any comments on anything I was talking about so far? Because I'm just running through it.
Yeah,
All right.
one thing I just want to, I've seen in the past, when you use Rayon, right? It gives better performance if you batch things. Like usually we do a
Yes.
pair iter in a loop, right? You just say pair iter. Instead, if you can batch it in like 8s or 16s or stuff like that, it will usually give you better performance.
Yeah. So basically, when we are sending a big blob as a block, we will have multiple records. So we will chunk that block into records, and then we will process those records, however many we have. And we should get about linear improvement relative to the number of cores you have for those records. It's just a commitment, so it's like not the whole thing is parallelized magically, but a big part of it. Yeah. I spent a lot of time looking into this issue. It's quite an old issue. It is resurfacing again and again. We have renamed things, so now it's called a little bit different. It said missing segment headers list. I don't really know the reason. I have started Stack Overflow, Stack Exchange question. No insights from there. What I have tried to do in this pull request, and hopefully it will fix the problem, so we will be able to narrow it down. Basically, we have slot worker, which I've just shown, where we are claiming slots one by one. And when we are producing block locally, I have noticed that some of those errors, at least, are caused by the forks. And supposedly you can produce a block locally, and then you can receive the same height from someone else. Maybe something somewhere within Substrate happens to be running in a weird order or something. So what I decided to do is take our slot worker where we are producing blocks, and from here fire the same notification block importing notification sender through block importing notification sender. So basically we know that this block will be imported right now because we have just produced it. Like it will be valid. So we can notify a little bit earlier before all of the block import pipeline kicks in. So we are like doing a little bit earlier, and hopefully, and it will be duplicated later. Like it's not a problem that we are firing it like 3 times. And hopefully this will cause that issue to not happen anymore. The challenge is on the Gemini 3D, this issue is already included, but we have majority of nodes not upgraded. So we do still see those messages, but hopefully it will resolve and we will have a better insight in where that problem might exist. This is just like educated guess. It's not guaranteed that it will fix anything. That's why the issue is not resolved yet. Just an attempt that maybe it will help. I don't have better ideas yet. I hope it makes a little bit sense for you. All right. From there was Rust upgrade and there was a Substrate upgrade. Those were long and fun, but we did it. I don't think there is much to talk about. There are like a bunch of things that they have done upstream that I have noted here that are worth reading into. But otherwise, not super exciting. There was another improvement for performance. I think some of the other parallelization I was able to cut on my machine the time in half for running archiver tests, which was helpful. And that's where Shamil noticed about the same. So that was great. Just more ray on throwing at things. Then there was another dependencies upgrade. We have removed finally one of the overrides. Those are the annoying things we have in the root cargo toml where we are running a specific commit. We can finally use upstream. So that was nice. Nothing too exciting. There was an interesting Stack Overflow here. The idea is that we are using a data structure, which is called, I think it's in pieces in here. It's called raw record, and that data structure is basically like a container for array, which is quite a big one. It will be about 1 megabyte on my branch for the new consensus. And as you can notice, it is not like allocated to the heap or anything. In some places, we do want it to be on the heap. Like in most places, we want to have it on the heap or as part of a vector, because otherwise stack will be overflowing. There is a bug in Rust, though, this very, very ancient bug, where if you just call box new and you put that into that, it will first allocate it on the stack and then move into the heap. And you will get stack overflowing even though you want to allocate it on the heap. So I have created a few of these methods on different data structures, which will give you boxed version that doesn't cause stack overflow. The basic observation is that our data structures are just plain data. So 0 bytes filled data structure is a valid invariant. So we can just allocate a box of a corresponding size, which is filled with zeros, and we can just assume it is initialized because zeros are fine. That way we are avoiding the problem, and now we are using these consistently across the code base. It helps us to remove some of the unsafe we had in other places. Like here, we were constructing record history segment manually, and we had the comment and everything, but now we can just call this method and not worry about unsafe everywhere else outside of the subspace core primitives. So another convenience thing, safety improvement and that kind of thing. Hope it makes sense. Hopefully this will be resolved at some point and we can just call box new until then. And even that is like an unstable feature in Rust. So unstable Rust, it would have been even uglier. All right. Some of the changes I was working on in the local branch, which are non-breaking changes, basically a few commits. There are some methods which are unnecessary actually and not exactly correct. Then there were some other methods exposed and some other things. And we also have our sector ID renamed to legacy because there will be a new one for the new version of consensus. With slightly different computation inside, and there is also a small fix for this that I have fixed upstream, so I will just upgrade to the library and delete this workaround in the upcoming pull requests. Otherwise, just some improvements for the data structures. And there was also update of the Chia proof of space. Basically, it seems to work by accident. I have found one of the few issues and I reported it upstream, and they said that, yeah, we solved that before mainnet, but we decided to not bother with K20 and smaller and fixing anything for that. And K17 is even not supported officially. It's K18, the minimum. We have just decreased that for ourselves. What I ended up doing is simply doing try catch, classic, and just treating those as invalid when it happens. So we can move forward. But I think the long-term solution will be to just rewrite this in Rust, but only the first phase out of 4 that are present in Chia, because we don't care about the 3 others. So we can save both computation and we can also maintain it in a way that doesn't throw exceptions out of nowhere. It was very inconvenient to debug because of the FFI boundary. Rust was just saying like something somewhere from different language, throw an exception. Good luck figuring out. It was not fun. So these are the things I have in a way that were reviewed. I hope they make sense. Any other questions? All right, I can probably talk about the p size, why we don't have 10 megabytes, as Shamil asked. This is a trade-off, basically. When we have 10 megabytes, it takes longer to actually fill those 10 megabytes, which means that if someone uploads something to the chain, they will have to wait much longer for that to actually be archived and included in the history. That's one thing. The other thing is overhead for data retrieval. If you want to retrieve a picture and that picture is, let's say, 200 kilobytes, you will have to download at least 10 megabyte blob if you don't apply other optimizations, and then extract 200 kilobytes from there. So the bigger p size is, the more efficient it is to retrieve big stuff. But for small stuff, it's actually a decrease in efficiency. So 1 megabyte is like a middle ground kind of number that has nice trade-offs in both directions, and there are probably some things on the consensus level, like on security level, related to the p size. So that's why 1 megabyte for now. It can be maybe half a megabyte. We are still kind of thinking about that, but 1 megabyte is what we are running with right now.
Oh, thank you.
Okay, I can probably show you a little bit of sneak peek into the future of consensus. Let me probably describe it to you a little bit. I'm not sure how much you remember from the talk that Daria did, but I was basically like looking at this and thinking, and to the degree that I can implement it, and I have some intuition how to explain it now. So I was initially implementing a slightly different version of consensus, but turned out there are problems with that. So we are actually implementing the correct version now. There are some challenges though. So the way it works, as before, we have a segment, and there is a what is called here verifiable sector construction, basically a way to figure out which pieces will be part of that segment. So that's easy. We are just taking the history. We are like doing some modular division and stuff like that, and we are figuring out these are our records. Then we need to encode these records, and the way we do that is kind of interesting. So let's say we have a record. What we will do, we will expand it to X with the ratio coding. So we will get some bigger record essentially on the output. So if this is about 32 kibibytes, then it will be 64 kibibytes roughly. And then from there, what we will do, we will actually try for each chunk, and each chunk is a scalar from the KZG, which is 32 bytes, actually 254 bits. We will try to find the quality for that index using Chia proof of space. So we have a table created before that, and we are just querying each index one by one. If we are finding quality, which is a 32 byte kind of hash, then we will take that chunk and we will XOR it with that quality, and then we will include it in our final kind of encoded version of the record. So this is like an encoding step. If you don't find it, we just skip it, okay, for now. And then we will try to find the same number of qualities as we had chunks originally in the record. It will be different indices because we've expanded that to X, but we will at least hopefully have the same number. Most of the time it is the case. For 99% of pieces, that is the case, or records in this case. However, sometimes we do not have enough qualities, like it is probabilistic kind of process. So if that happens, then we are going again through a ratio coded record, and we are picking enough of those chunks which were not encoded, which we have skipped previously. And we like add it to the very end. So let's say we have encoded like a chunk 0 and 2 and 3, and we need 4, then we will take 2 and we will unencoded add to the very end. And then we have 4 before, we have 4 after, even though ratio coded it's 8. Okay, makes sense? And we have a bunch of those records, and we can imagine them as rows where encoding has, okay, let me scroll back, it will be easier here. So we can look at this picture. We have a bunch of records. They are like rows, and each of them after encoding has like columns with chunks. So this is how we like treat it in memory when we are encoding them. But then before writing to disk, we are actually take the first column, or like not the first column even. We will check for each record, and if it has either encoded or unencoded chunk that was in the ratio coding and at index 0, then we will pick it for as bucket 0. So we will check each record one by one. If there was a index 0 picked for that particular record, we will include that. Then we will move to the index 2, 1, 2, 3, and so on. So we will have as buckets which are variable size, because not all records will have the first or the second or whatever index picked, right? It's probabilistic process. Does it make sense? Like, can you visualize it in your head? So basically, for different records, we will pick different offsets here. And the first S bucket is all of the chunks that were encoded or not encoded or otherwise picked for every record, like record 0, 1, 2, 3, like we are just going from top to bottom in here, and we are picking them. So in the end, every record has the same number of indices picked for whatever reason. So the total size of all S buckets is the same as total size of all of the records, but they're just arranged differently. They're like almost orthogonal, but not even like actually like clearly vertically. Like, it is strange. So that's how we write it to disk. Why? Because we want to audit it that way. We want to audit the first indices. We want to audit the second indices separately. So we like arrange the whole sector using S buckets. But now we have a problem because S buckets are all different size, and we don't know where to read if you need to audit S bucket, let's say 11. So that's a challenge, and the challenge not only to like how to do it, like we can probably do it somehow. The challenge is how to make it efficient. Efficient in terms of the disk storage, how we store that mapping efficiently, and also if we need to store it in memory, then how do we occupy as little memory as possible. I thought about that quite a bit, and I came up with a few data structures which help with that. The tricky one is actually called sector contents something. Let me see. Sector contents map. Basically, when we look at this record, when we are transforming that, that record becomes 2 size bigger. So what we can do, we can for each record allocate a bit field, which has as many bits as we have indices in a ratio coded record. So in our case, 2 to the power of 16, 65,000 something indices. And then for each index for which there was a proof of space quality, we will set 1. For the rest, we will set 0. So later on, when we are reading this bit field again, we not only know which indices were picked and successfully encoded, by counting how many ones we have, we know how many there was not, like how many we were missing, and then we can go back and read those that were skipped as well. So basically, this bit field is sufficient for us to decode everything we need to know about record. And if we know what happens to the record, we can kind of translate that into how it was stored in the S buckets, even though there are like a few steps to that. So basically, there is this data structure which stores all those bit fields for all of the records as they were ratio coded. And then to make it a little bit more efficient in some places, there is another extra thing which is only stored in memory. It's not stored on disk, which stores how many indices did we pick and set to 1 in each record. It helps us with computation. And from there, we have a lot of different methods which allow us to iterate over record bit fields directly. We can also iterate over how many, how big are each S bucket from 1 to the power of 16. We can iterate also over record chunks. So we can have iterator of these things. And there are a few more iterators which are used in different places, which like due to the fact that these bit fields, they are all fixed size and we know what is there, we can like chunk in different ways and we can iterate strange shapes, and we can basically reconstruct everything. The challenge is that this data structure becomes a hot path, actually. It is used very heavily during plotting and during farming. There is still one bug with the plotting that I'm about to squash. But otherwise, that is the smallest data structure I can come up with that encapsulates necessary information. And that data structure occupies a little bit more than 100 megabytes per each terabyte of plotted space. That is something you will have to store in memory, or you can read it from disk, but then you will have about 2x IOPS required for audits. So every time you audit, you will first need to read this metadata, which is about 130 kilobytes per sector. Then you will have to like interpret that, do the iteration stuff, and then you will have to be able to actually audit. So that is not very fast right now, but that is kind of what we do. I hope it makes sense. I think I'll not go into the other details unless you want. We have not that much time. But yeah, we have plotting, we have auditing, and we have proving. I will probably show later how exactly it is structured once all of the bugs are fixed and pull request is out. But the implementation is on the way. There will probably be another pull request with things like here, but breaking changes. So it will still produce blocks, it will still work, but it will not be compatible with Gemini 3D. That's the only difference. It will a little bit make the diff a little bit smaller for the actual final pull request. Yeah. I hope this kind of visualization makes sense. I will try to reword slightly the way the specification talks about things, because it, as you implement it, there are like more things discovered, and some things are not the same way as described here. But the result is the same, so that's good. And I think there might be even a presentation later on to visualize how things are translated from the pieces to the plot and back. Interesting stuff. Okay, but that does anyone have questions about this or anything else?
Yeah, so I didn't
Do we
follow.
have sorry, Rahul, please go.
Go ahead. Go ahead.
Okay. Mazar, do we have some estimations when we are going to replot sectors or recycle sectors?
Yeah. Currently, not exactly. There is this section which is not finalized. I think the initial implementation will not have expiry yet, but we will add it later. We have like fields in the metadata which says when it's expired and stuff like that, but there's no actual mechanism implemented yet.
Okay, thank you.
Rahul?
Hey, so I didn't follow why the buckets have different sizes. Maybe.
Yeah.
Somewhere.
Okay, so we have a record. Then we are ratio coding that it gets to 2 times bigger, and then for each chunk in here, we are trying to find quality of proof of space, basically a proof. And then for those indices that we find, we will actually pick that index into encoded version. So encoded version will contain 2 to the power of 15 elements out of 2 to the power of 16 candidates. So let's say if we are constructing S bucket number 2, which has index 1, but we didn't pick this index for the first record, then the first S bucket will not contain anything from the first record in it. That's why, depending on what these qualities say, each S bucket will contain a selection of 0 to 1300 elements from different records, but which records we don't know. Like some may be skipped because there is no proof for it. Does it make sense?
I see. Okay. So going back to the other data structure that you showed, I was wondering, like, can it be stored with like holes in this so that everything is of the same size?
Okay, so the only actual reason why we are doing erasure coding here, it's technically not necessary, is because this process of proof of space, it is probabilistic, and only, I believe, 70% or something like that indices or like trials will result in proof of space. So in order to maximize the probability that we will have all of the encoded chunks in here rather than unencoded, which will not be participating in the farming process. They'll just like added there just to fill the gaps. Just to do that, we are ratio coding it 2x, and then we are increasing our chances to 99% that every record will have all of the encoded stuff. That's the only reason we are doing inertia coding. If we didn't do that, then we will have like 30% of chunks here that are not able to participate in farming, unfortunately, which is not great.
I see.
And due to KZG properties, ratio coded originally doesn't matter, like all the proofs are the same, so that's nice.
Got it. Yeah.
Awesome.
Yeah, but other question I was like, in the other data set showed where it showed bitmaps. If would it make sense just to store holes in the bucket so that everything is of the same size? Okay.
Yeah, but then we will be wasting a lot of space. That would have been nicer, but that means wasting a lot of space.
No, like I said, if it's going to be 99% time, we'll have something there, and only small percentage of time you will have like an empty hole. Kind of.
No, okay, I get what you're saying. So effectively, we have 2 to the power of 16 as buckets, right? But we have enough records or like record chunks to fill 2 to the power of 15. So effectively, if we had all of the indices filled either with like empty stubs and actual data, we would have to waste half of the space. We can't do that, but it feels like storing 2.6 gigabytes instead of 1.3 doesn't really make much sense, and we don't need the other 1.3 because we can reconstruct the data with what we have already. So this is like a trade-off between efficiency and kind of ease of implementation.
Okay.
We could have stored more data structures for this thing in here. But again, the question is whether 100 megabytes is too much for 1 terabyte or not. Because if you have, let's say, 50 terabytes plot, then suddenly you need 5 gigabytes just to store these maps. That's not accounting for the rest of the application. So yeah, a little bit of an open question. Maybe we will optimize it somehow by using even more memory, but the gist of it is that the new farmer will be quite memory hungry, especially during plotting. Even during farming, it will actually, once there is a candidate, winning candidate, it will read the whole sector, which is 1.3 gigabytes. So it will be at least 1.3 gigabytes plus some stuff in memory at the same time. And if you have multiple disks, then for each disk, you will occupy that much memory. So yeah, that's why we might want to go with smaller pieces, but we will see. That's where we are at right now.
Yeah, I guess the other idea I had is like maybe store this in like parity DB or something like that in stock memory. So it will be like a middle ground. You can store a lot.
It is already stored on disk. We can read it from disk anytime. It's not that difficult. It's just that we need to stick to the beginning of sector. We need to read it, then we need to like parse it, and then we only can try to even audit. Without that, we don't know where this bucket starts in the first place.
Yeah, I'm thinking like using a DB, like a cache kind of thing or something. But yeah.
This is essentially our cache kind of thing. But maybe a 1 gigabyte is fine for a terabyte. If you decide that is the case, then we can make it even faster by just using more RAM and have more denormalization of data. Because this field is essentially a denormalized version of this, but it is quite small. So, okay. Thanks for your attention. Thanks everyone on YouTube for watching, and we'll be talking about more stuff next in next 2 weeks. I think it will be. I should be able to present you the consensus implementation at that point. Hopefully, fingers crossed. Okay. See you later.